and stator blades. The rotor blades take the air and force it backwards through the engine, while the stator blades channel the air so that it hits the next series of rotor blades at the right angle. As the air is pushed through the compressor, the space available for it is reduced, and it gets literally packed in, so much so that compression ratios of up to 40:1 are possible. The compressor is driven by the turbine. One turbine can drive the whole compressor, but now there are often 2 or 3 turbines in an engine, each with a separate shaft that rotates a different section of the compressor. The fact that the sections can then rotate at different speeds means it is easier to maintain the correct overall flow of air through the engine, and the entire engine can be made shorter and stiffer. When the air reaches the combustion chamber, it's at a pressure approaching 600 psi, and it's travelling at more than half the speed of sound. Fuel is difficult to burn under these conditions, so a combustion chamber provides the correct environment, an area of more slowly moving and swirling air that is sprayed with fuel. This mixture will ignite, and the increase in heat energy is quite considerable. The burning gas can be as hot as 2,100 degrees centigrade, and at this sort of temperature, the metal the turbine blades are made of will melt. However, cooler air continues to be mixed with the burning gas to lower its temperature before entry into the turbine. And more cool air that had not been taken through the combustion chamber but diverted for cooling purposes brings the operating temperature of the turbine blade down to a more manageable 1,000 degrees or so. In some ways, the turbine is the compressor in reverse. Nozzle guide vanes channel the gas onto the turbine blades, which are shaped so that the gas flowing over them is used to generate the optimum power. The blades are slotted onto a disc which rotates the shaft that is connected forwards to the compressor. Often, as well as driving the compressor, the turbine will also provide ancillary power to even drive a propeller. It is vital that turbines are perfectly designed and manufactured. Just this one stage, the high-pressure turbine can generate up to 70,000 horsepower, at which point the blades will be spinning at 1,500 feet per second. That's over 1,000 miles per hour. So everything must be done to ensure that the passage of gas through the turbines is as smooth as possible. Similar care is taken as the gas leaves the engine through the propelling nozzle. It is these exhaust gases that provide the thrust to power the engine, so essential that they are propelled from the engine at exactly the right speed required by the aircraft. This is largely determined by the size and shape of the propelling nozzle that can give a kick to the gases as they leave the engine.